Hello and welcome back. The following problem states rate constants for the following reaction were measured at 4 different temperatures. Determine the activation energy in kilojoules per mole for the following reaction. So as you can notice, I have 2 different tables. I have a table displaying temperature and the rate constants, and I have another one that's looking at 1 over temperature and ln of K. The reason why we're doing this is because this is a second order rate reaction, and because we're looking at the change in temperature to the rate constant, we are dealing with the Arrhenius equation, which states ln of K is equal to the minus of our activation energy divided by R multiplied by 1 over temperature plus the ln of A. Well, remember, we can equate this to the equation of a line where ln of K is y. The slope is equal to this variable. 1 over temperature is our x, and our slope, or our y-intercept, is b for the ln of A. So once we have that, and we're looking for the activation energy, all we need to do is find the slope, because the slope is equal to negative of our activation energy divided by R. And in order to find our slope, we know slope is equal to the change in our y-axis, so y2 minus y1 divided by x2 minus x1. We're going to go ahead and select 2 of our y and x variables from the second table, that's 1 over temperature and ln of K, and I'm going to pick the following ones. Negative 1.69 for my y2 pair, and so the accompanying x2 is 3.25 times 10 to the negative 3 Kelvin, minus negative of 2.29 minus 3.36 times 10 to the negative 3 per Kelvin. Well, once we have that, this simplifies down to negative 5.45 times 10 to the 3rd Kelvin. Well, now we can go ahead and plug this in to the following expression. And so we get the activation energy is going to be equal to negative of my slope times R, which is equal to negative times 5.45 times 10 to the 3rd Kelvin multiplied by 8.134 times joules per Kelvin mole. Kelvin and Kelvin cancel out, and activation energy is equal to 4.53 times 10 to the 4th joules per mole. Make sure to always remember that if you're looking at how rate constants change in a comparison to a temperature change, to always use the Arrhenius equation. Thank you.